Alright, welcome to the video on converting to vertex form. So this one is going to be about a method called completing the square. Completing the square is a trick that we can use to work backwards from a trinomial into a binomial squared. And if you remember, vertex form is y minus k equals a times x minus h squared. The key to getting vertex form is getting this binomial squared, this x minus h squared. So we're going to take something that's a trinomial and try to work backwards into a binomial squared. So an example of what this might look like is if we had x plus 5 squared here, if we were to square it out, it would be x squared plus 10x plus 25. Okay, so that means that if we have in our equation x squared plus 10x plus 25, we could go backwards and write it as x plus 5 squared. So there's a couple of steps to this process. First, we're going to outline what the steps are, then we'll do some examples. So the first thing you have to do is figure out what your perfect square is. So the perfect square is always half the middle number. So half of the middle term, half of this number is your perfect square. And you can see in this example, it's x plus 5 squared because 5 is half of this middle number, 10x. So the last number is the square of whatever that half the middle number. So this 5 right here, which is our perfect square, if we square it, we get 25. So I've said here, square it and add it to both sides of the equation. So if you have an equation, y equals stuff, once you've figured out what this b squared value is, you might do like plus 25 on this side and plus 25 on this side. I want to quickly mention there's an alternate option. That's one option. The other option is if you have the same equation, y equals stuff, and you've determined that you need to add 25 to this side in order to make a perfect square term, you could do plus 25 on this side minus 25 all on this side, because if you add 25 and you subtract 25, you've actually not changed it at all. But now you can look at this part as a perfect square, and then you have a minus 25 left over. And we'll see a couple examples in a second. But once you have your perfect square part, you can write this as something squared, and then you'll have this leftover term that's just hanging out. But you can see this is starting to look a lot like vertex form. So again, half the middle number squared is the amount that you add to both sides. Then write your perfect square part as a binomial squared, and finally finish solving for x. So here's a couple of examples. Our middle number is going to be 8, and we want to take half the middle number. So our b value is going to be 4. Not b as in standard form, but just as in a plus b squared. And so if we want to get the b squared, that's going to be 16. So half the middle number squared is plus 16. But if I add 16, I should also subtract 16. Either I could subtract 16 on this side, or I could have added 16 on the other side, but it's the same thing. So now this part here, that's my perfect square. So I can write this as x plus 4, which was half the middle number squared, minus 16. So we can write x squared plus 8. It's exactly equivalent to x plus 4 squared minus 16. And now you can see this is a parabola, which has been shifted left 4 and down 16. Let's try this one here. We want to take half the middle number, which is negative 14, divided by 2. And we want to square that. So I'm going to do it all in one step here. Half the middle number is negative 7. Squared is positive 49. So we can do plus 49, and then we can do minus 49. Again, if it was an equation, you alternatively could have added the 49 to the other side. So this whole thing here is a trinomial, but it's a perfect square trinomial. So we can write it as a binomial squared minus 49. And it's a perfect square of half the middle number, which is 7. In fact, negative 7, so x minus 7. So this would be a parabola which has been shifted right 7 and down 49. So there's a lot of cool things you can do with these kind of completing the square techniques. You just have to make sure that you're following the golden rule when you're adding or subtracting things from both sides, and you have to follow PEMDAS when you're simplifying expressions. Okay, so that works really well if you have just x squared as your leading term, but you could have a complication where the leading term might be 2x squared or 3x squared. So if there's an a value there, the best thing to do is to factor out that value and then complete the square on what's left behind. So for example, here we've got 2x squared plus 36x minus 50. So when we're completing the square, we just need to have an x squared. So we'll take out a 2, and we're left behind x squared. If we take a 2 out of this 36, it's plus 18x. And I'm going to write plus blank. And then I'm going to close my parentheses. Right now that's nothing. And then this minus 50 is still over here as minus 50. The reason I didn't factor out a 2 from the minus 50 is because that 50 is not the perfect square that we need. And so it doesn't matter right now. We're trying to complete this square. We only care about the x part and the x squared part, because we want to take half of this middle number squared, although instead of the middle number being a 36, we had to factor a 2 out, so now the middle number is just an 18. So half the middle number squared. To get from here to here, we take half the middle number squared, which is 18 divided by 2 squared. Half the middle number is 9, squared is 81. So I've added 81 to this side, except this is inside parentheses, and there's a 2 right here. So this 2 is actually multiplying to the 81. So the amount that I've really added to this side is twice 81, or 162. So if I add 162, which I just did right here, twice the 81, then I also need to subtract 162 from this side. Or alternatively, I could have added 162 to the y value. But since we already have y equals, typically, in my opinion, it's usually easier to add whatever you want right here, and then simultaneously subtract it outside the parentheses. Okay, so now we have y equals 2 parentheses. This part here is a perfect square, so it's going to be something squared. So it's a perfect square of half the middle number, which is x plus 9. And then outside we had a negative 50, and then we subtracted an additional 162 for a grand total of negative, 212. So the numbers are large, but that's okay. So this original equation here in standard form is exactly equivalent to this equation here in vertex form. So from standard form, you can see it's been stretched by a factor of 2, and it's got a y-intercept at negative 50. From vertex form, you can see that the vertex is located at negative 9, comma, negative 212. So it kind of makes sense. You're going down 212. The vertex is really, really far down, and then it opens up like a parabola. When it hits the y-axis, it's going to be a lot higher than that, but still negative, and it hits at negative 50. And again, it's been stretched by a factor of 2. So, converting between these different forms, they all require different techniques, and completing the square is just one of the many tools that you'll learn.